Hello guys, I'm gonna be solving some examples about how to find the R equivalence or R total in circuits which have like more than 2 or 3 resistors in different arrangements. So you can be more familiar with the concept of parallel and series resistors. It's very important to learn this because further on, when we go into more analysis method for circuits, we're gonna need to know this properly. So here we want to find, it's important first of all where we want our R equivalent to be. We want it here. We want to know the R equivalent at these 2 points. Sometimes they say R equivalent here, someone says RAB, they put A and B in here. It doesn't really matter. All we need to know is that how to find if two resistors are in series or are in parallel, and then according to the formulas that we know, we're gonna calculate the equivalence resistor. And one more very important thing that we need to know in order to not make mistakes is that, for example, if we say these two resistors are connected only from one side and then from the other side they're connected to other resistors, so they are in series, and then we're gonna add them up. Where do we write that added up resistors? We're gonna either write it in the place of this one or this one. We're not gonna write it anywhere else, so we wouldn't make any further mistake. Usually we write it in a place of the resistor, which is gonna make it simpler for us to further on calculate the rest of our resistors. So here, as I told you now, they are only connected from one side, so they're in series. But there's also this one in here. This 4 ohm resistor is also connected with this one only from one side, and then from the other side to others. So this one is also in series with this. So these three, they're all in series with each other, and their equivalent circuit, let's say our equivalence 1, is 5 plus 4 plus 3, which gives us 12 ohm. So I'm gonna be writing its circuit again so you can understand better with our new equivalent circuit that we found. So I'm just gonna be writing all the resistances in their own place except the ones we calculated their equivalence. As I told you, you have to write this number instead of one of this resistance. I'm putting it here so we can easily understand later on. If I put it here, we can easily know, okay, these two are in parallel because they're connected from both sides. They're also in parallel. Like, it makes it easier for us in the figure to understand it. So we know these two. We say these two are connected from both sides to each other, so they are parallel resistors. So we said our equivalence for parallel resistors is, we said when we have two, remember that formula, we said their multiplication over their sum, which gives us 3. 48 over 16 is 3. So we can write this 3 here, or we can write it 3 here and then eliminate this, or 3 here and then eliminate this. Of course, it's easier to put it here because it's gonna be closer to the rest of our resistors. So I'm gonna be again drawing this circuit again with our new equivalent resistor. And now I'm putting, instead of this resistor, the equivalence of it with the other resistor, which is 3 ohm. Here, as we can see, they are connected, these two, only from one side. From the other side, they're both connected to this one. So we say these ones are also in series, and it makes it our equivalence 3. Let's say 3 plus 3, which is 6 ohm. Now I'm gonna rewrite the whole circuit again You don't have to rewrite it every time, especially when you get more familiar with them, but I'm writing it again for you guys so you don't get really confused. You can understand it better. So as you can see here, this one and this one, they're both connected from both sides, so they're parallel. And the R equivalence for the parallel is their multiplication over their sum, which is 36 over 12. So I can write this 3 as I told you here or here, but here it's easier because we can easily eliminate this, and it's closer to our other resistors. So I wrote that 3 in here. Here it's all easy now because we only have 3 resistors, which this one is connected to this one from one side, not from the other side. This one is connected to this one from this side, not side. So there are equivalents, or R equivalence total is the R equivalence of these 3, which is 4 plus 3 plus 3, which is 10. So it's not that complicated. It's really easy if you try to simply understand them and then redraw them and not make any mistakes and put every equivalent circuit in its place and that it should be. And start from the right place. We shouldn't start from here. We should start from here because we want to, at the end, we want to get here to here with one resistor. So it's better to start from here. I'm gonna be solving one more example for you guys in here. It's my base seem a little bit more complicated, but it's not. As you can see here, first of all, we said we start from here, so the most right one when we want the most left equivalence. They're connected only from one side, from the other side they're not connected to each other, so we say they are in series, and their R equivalent is 5 plus 1, which is 6. And here we see that if we want to come here, it's gonna get a little bit complicated. So it's better to do is to find the equivalent circuit of these two and then put it here. So what do? We say that these two are connected from both sides to each other, so they are in parallel. So what I do is that to find their R equivalence, which is their multiplication over their sum, which is 2. So I'm gonna redraw the whole circuit again for you guys with our new R equivalences. Here you may say, why did you put this 2 ohm in here and not here? You said we should only put it in here or here in the place. It's correct, that's what we should do, but actually if I'm putting it, let's say it is 2 ohm not in here and it's place of this, like this one, it doesn't really matter, then we wouldn't have this and it's still gonna be in series with this one, and it doesn't really make a difference. So let's do that. Let me just put it because I don't want you guys to get confused, but that's what we should usually do when we know about these circuits and their resistors more, but not to not confuse you guys, I just put it instead of one of these resistors and then eliminate the other one. As you can see in here, I can say this one is in parallel with both this, but to make them to calculate it, first we add these two that are in series with each other, which are they're connected from one side, and then from the other side they are not connected to each other. So we say these are in series, and then we find their R equivalence and say it's 4. And then we say, yeah, this one, the R equivalent of this one is in parallel with this one, because they will connected from both sides. One resistance will be connected from both sides to this resistor. Now these two parallel ones, there are equivalents, which be their multiplication over their sum, which is 2.4. So I'm gonna redraw this whole circuit. We have 4 ohm and 8 ohm in here, and then here we found the equivalence of all these three, and then we put it in place of these two, which is here, which is 2.4, and our equivalence here. Now it's easy, they're all connected from one side, so our total in the whole circuit, it's the R equivalence of these three, which is their sum, and which is 14.4.